Imagine building a bridge so long it disappears into the horizon, decades before GPS even existed. In the 1950s, crossing this lake could take hours, and storms often made travel impossible.
People believed a bridge across open water was simply impossible.
The greatest challenge wasn't the distance. It was building in open water with no GPS.
Every measurement depended on mathematics, skilled surveyors, and remarkable precision.
Okay, slowly lower it down now. Reading steady depth at 40 feet, keep it coming.
We're seeing heavy siltation at the 12-foot mark. Roger, 12 feet. The data looks consistent with the previous dives.
One mistake could throw the entire bridge miles off course.
Tugboats hold position. Crane, engage the slings and take the tension. We're lifting the first pile now.
The first pile was about to enter the lake, beginning one of America's greatest engineering achievements.
Every pile had to be placed with incredible accuracy, without satellites or digital navigation. Survey teams relied on theodolites, compasses, and pure mathematics. Wooden marker poles became the only guide across 24 miles of open water. Next came the hardest job, driving concrete piles deep beneath the lake. Each foundation had to penetrate soft mud before reaching stable ground. Powerful floating cranes worked tirelessly in every direction. Storms often forced construction crews to stop for days. Storms often forced construction crews to stop for days.
When the skies cleared, work resumed immediately.
Piece by piece, the bridge slowly reached farther into the lake. But the greatest test was still ahead, connecting two ends with perfect precision. Now came the most dangerous phase, building farther from land than ever before. Every bridge span arrived by barge and weighed hundreds of tons.
All right, men, easy now. Steady, steady. A little more to the left, slow lift.
Even the smallest mistake could delay the project for weeks.
Powerful hydraulic systems lowered every section into its exact position.
Reading indicates a microfracture at the weld joint. Hold position for sensor scan. Acknowledged. Maintaining depth and illumination.
Construction continued through heat, wind, and relentless weather.
Day after day, the bridge stretched farther toward the opposite shore. Finally, the two construction teams could see each other across the water. Only one final connection remained, and history was about to be made. After years of construction, only a few feet separated the two bridge sections.
We are showing a slight deviation at the midspan support.
I see it here on sheet 3.
The alignment target needs recalibration before the next pour.
An error of mere millimeters can multiply catastrophically across 24 miles. We must achieve absolute precision.
Slowly, the final gap disappeared forever.
For the first time, vehicles could cross the lake without a ferry. But engineers still had one final challenge: proving it was safe. Thousands of tons rolled across the bridge during its first tests. The results exceeded every expectation. America had achieved what many believed could never be done. Building the bridge was only half the challenge. Keeping it alive was even harder. Hidden expansion joints allow the bridge to expand and contract every day. Powerful concrete columns quietly withstand millions of waves every year.
The application of this advanced protective coating creates a near-invisible layer of corrosion resistance, critical for long-term maintenance.
Regular inspections help engineers detect tiny problems before they grow.
More than half a century later, millions of vehicles still cross safely.
What began as an impossible dream became one of America's greatest engineering achievements. But perhaps the greatest achievement wasn't the bridge. It was proving impossible ideas can become reality.
When the bridge finally opened, it changed life across southern Louisiana forever.
Travel that once took hours could now be completed in minutes.
Engineers around the world studied its remarkable construction techniques.
For years, it held the record as the world's longest bridge over continuous water.
The data coming in from the drone confirms the stress points on the main support structure.
Good catch. We need to cross-reference this with the original blueprints immediately.
Yet none of today's technology existed when this bridge first began. Their greatest tool wasn't technology, it was human determination.
What once seemed impossible now carries millions of journeys every single year. Before satellites, before GPS, ordinary people built an extraordinary bridge that still stands as one of America's greatest engineering achievements.
The engineering is incredible. Look at the scale of it.
The colors of the boats below are so vibrant in the sun.